Children, let us discuss chapter 9, area of plane figures, class 9. We have learned how to find the area of a rectangle, square, parallelogram, triangle and rhombus. In this chapter, we will learn how to find the area of a trapezium, quadrilateral, circle and a square. First, let us review what we have learnt about the area of a rectangle, square, parallelogram and rhombus. So children, a small activity for you. Find the area of following figures. Here it is rectangle with the length and breadth 20 cm and 10 cm. Triangle breadth 10 cm, height 12 cm, and the rhombus whose diagonal is 10 cm, and other diagonal BD is 12 cm, and this one is a parallelogram, base taken as A 14 cm, height 6 cm, and then is square of side 4 cm, and obtuse angle triangle whose base is 4 centimeters and height is 10 centimeters. Now we need to find these areas using the appropriate formulas. So just observe this obtuse angle triangle. The height is outside of this triangle, whereas in acute angle triangle height is inside of the triangle. Just remember that point. And then next, see one by one areas of above figures. Area of rectangle, length into breadth 20 into 10 200 cm square. Area of triangle, half into base into height, half into 10 into 12. On simplification we get 60 cm square. Area of rhombus, half into d1 into d2, that is half into d1 value 10 and d2 value 12. So that's why on cancellation we get 2 1s are 2 5s are, that is 5 12 are 60 cm square. So as you know all these formulas. Area of a square is side into side, that is 4 into 4 cm square. 4 into 4, that is equal to 16 cm square. So area of a square is side to side, that is equal to 4 into 4 16 cm square. And then area of parallelogram, base into height, that is A into height, that is A into H, 14 into 6, that is equal to 84 cm square. Area of obtuse angle triangle, half into base into height, half into 14 into 10, so 2 1s are 2 7s are 7 10s are 1070 cm square. Now see this table, just this is also an activity. Here we have figure, measurements, formulas for area and area of the given figure. Okay children, just make a note all these things and next take a pen and a notebook and practice all these things. Okay. Here we have the square. So here the square figure, side of a square is 15 cm. Area is equal to side into side, that is 15 and 15 is equal to 220 cm square. And the rectangle length is 20 centimeters and area is L into B, and area value is also given to 80 cm square. So then we have to get breadth. So how can we get breadth? Simply breadth is equal to area by length, that is 280 by 20, then we get 14 centimeter. Now triangle, so he has given base and height. Base we need to find, height is given, the area value 38 cm square is given, and the area of form is also there, half into base into height. Now we need to find base. Simply substitute that area value 38, height value 19, then on simplification you get base as 4 centimeters. Next, parallelogram. So here also they gave base and the area of the parallelogram formula B into H, and area of that figure is 56 cm square. So by substituting all this we get simply that base is 8 cm square. Simply divide that area by base. Now next, here we have the 3 different figures. So we need to get area of these flats type figures. So I am taking one live example. Ramu wants to purchase a flat to to construct a house for himself. Some of the shapes of the plots visited by him are shown below. A, B, C. Plot A in the shape of trapezium. Plot B in the shape of quadrilateral. Plot C is in the shape of pentagon. Now actually he wants to calculate the area of such figures to construct his house in this field. That means here we need to get the formula of the area of trapezium. Okay, that's why we are learning areas of the trapezium particularly. So actually what is the trapezium? Once again we call that definition. So here a quadrilateral in which opposite pair of sides are parallel and the other two pairs are non-parallel. Okay, so A and B seems to be same, so those are said to be simply quadrilateral, nothing but trapezium. And next here third one is just like a pentagon. In that also just divide that pentagon into two figures. One is a triangle, another is a trapezium. Okay, now we have learned how to find the area of rectangle, square, parallelogram, triangle and rhombus in lower class also. Now in this chapter we will learn how to find the area of trapezium, quadrilateral, circle and a sector. Mainly trapezium, quadrilateral. To find out the formulas or to obtain the formulas of these two figures, we need the above formulas, that is rectangle formula, triangle formula especially. Okay, that's why we are recalling that all the things. By using those formulas we are easily or we can easily obtain the formulas of trapezium and quadrilateral. Okay children, now let us see one by one. Area of trapezium. Here also I am taking one live example. Kumar owns a plot near the main road as shown in the figure. Okay children, first figure. Unlike some other rectangular plots in his neighborhood, the plot has only a pair of parallel sides. So that's simply you can say it as a trapezium. So it is nearly a trapezium in shape. Can you find out its area? Yes, actually it seems to like a regular plot, but we need to find that area by using that known formulas. Let us name the vertices of this plot as shown in the figure 1 by drawing CE perpendicular to AB. I am taking the first side, largest side as AB, smallest side as CE, CD, and I am just to draw a perpendicular CE to AB, and then we can divide that figure into two parts. That is, one is right angle triangle, other is a rectangle. So once again here, let us name the vertices of this plot as shown in the figure ABCD. Figure 1, by drawing CE perpendicular to AB, we can divide it into two parts, one of the rectangular shape and other one of triangular shape, which is a right angle triangle as shown in the figure 2. Now let us try to find out actual area of that trapezium. Here we have right angle triangle, we are just adding the area of a rectangle. Just that means we have to add the area of right angle triangle and the area of rectangle. By that way we can easily obtain the formula of the trapezium. Okay, this is one of the way. Thus we can find the area of the trapezium ABCD by combining the two areas as shown in the figure. So that is rectangle is ADC and triangle is ECB. Now area of ABCD equal to area of ADCE plus area of ECB. Then we can get easily area of that rectangle is length into breadth, that is length is taken as here A, breadth is H, so H into A or A into H, plus area of the ECB is half into base into height, that is base is taken as H, height is taken as C as shown in the figure. Just draw the figures and follow each and everything, and we get H times half to A plus C by 2, 2 is the LCM here, so we can write it as H by 2 into A plus C. Actually here A plus C is the length of full side, that is B, that is one of the parallel side B, and other parallel side is DC, that is A. Why? Because here AE is equal to CD is equal to A, so we can get the formula as H by 2 into A plus B, since A plus C equal to B. So actual formula of trapezium is height by 2 into sum of the parallel sides. Here height means simply the distance between the two parallel sides, that is CD and AB. Here CD is taken as A and AB is taken as a B. So like this we can get easily the formula. Now we can apply that one. So by substituting the values h is equal to 12, a is equal to 20, b is equal to 30, then we get area of trapezium h by 2 into a plus b. By that where we can easily calculate the area of the trapezium. So 12 by 2 into 20 plus 30, then we get 60, 12, 2 ones are 2 6s, simply we get 6 into 50, that is 300 centimeter square. Now let us see once again by seeing one more example to get better understanding. So here is a figure of a playground. Then we have to find the area of this playground. So see the measurements here. AE is equal to C, EF is equal to actually B, and FB is equal to D. Okay, that full length, bottom length is A to B is simply A. So actually it is a playground. Now solution. We can divide this as actually 3 parts, but here we cannot divide the figure into one rectangle and one triangle. So like this type of figures, we have to observe that edges of this that ground. So we got here A, D, C, B are the edges or the corner points of this full figure. Then here we need to divide this figure actually into a rectangle and 2 triangles as our convenience. Conveniently we can draw. That means you have to draw the perpendiculars DE and CF to the AB. That is, draw CE perpendicular to AB and CF perpendicular to AB. Okay, D and CF are the perpendiculars. So that a trapezium ABCD is divided into 3 parts. One is rectangle and DFEC is a rectangle, and other 2 triangles AD and CFP. Now see this. Area of trapezium is sum of the areas of triangle ADE and area of rectangle DEFC and the area of the triangle CFB. So area of a triangle, we know that half into base into height. So first base is C, height is always taken as h, half into C into h plus, and next rectangle breadth is B and height, that is actually breadth is h, length is B, length into breadth, that is B into h plus again here half into base into height, base is here D, height is h. So on simplification we get h times of 1 by 2 into C plus B into 1 by 2 into D. So on simplification we get h times of C plus 2B plus D by 2. So but 2B can be written as B plus B, then we can rearrange them h times of C plus B plus D plus B. So actually C plus B plus D, this whole thing is equated to A. So that's why h times of A plus B by 2. So like this also we get the area of a trapezium formula. Okay, so just do these examples perfectly and don't forget this formula. Okay, now let us see one more there's more and more interesting sums in our exercise 9.1. So see this here, divide the given figures as instructed. Then here we have the figure. So here we have to divide this into 3 rectangles by using this line at draw that line at that position, and other one is yes. So we draw these two as just like a perpendiculars from that edge points to the left side line. So we get easily 3 rectangles. Okay, children. So just observe and learn how to partition the given figures, how to divide the given figures. And next we have here that in this instructed is into 3 rectangles. Then here we have a figure just like U-shape figure. Now we need to divide into 3 rectangles. Just draw one line at here and another line at there. So by just draw the appropriate line segments to divide the given figures as instructed. Now very simple. Here we have hexagon. Again they are instructed as 2 triangles and 1 rectangle. Now here just draw a line segment at a triangle side and one more triangles. That is, we have to draw the 2 line segments to divide as our required. That is 2 triangles and 1 rectangle. Middle one is rectangle, middle one is rectangle, and either sides are 2 triangles. Now one more figure here. Yes, it is just like a pentagon. They are asking one triangle, one trapezium. Okay, where you can draw? Yes, at there, that at a triangle part. So we can get is one triangle. We get it as a one triangle and one trapezium. Now let us see here important sums. Now we have to find the area of this adjacent figure. Here by seeing this figure we can say easily area of triangle ABC plus area of a square. Here we have the two figures, one is ABC and other is square. So in this height is given, this full figure height is given as 6 centimeters and the square of each side is 4 centimeters. Okay. Now area of triangle ABC, we know that half into base into height. So then we need to get actually height, that is height of the triangle. So full height is 6 centimeters and the square height or square side is 4 centimeters. If you subtract them, then we can easily get the height of the triangle. Just observe the figure and try to understand it. 6 minus 4 is equal to 2 centimeters. So that's why we get area of a triangle is half into 4 into 2, that is, and cancellation we get 4 centimeters square. Then area of a square is side into side, that is 4 into 4, 16 centimeters square. Then therefore required area is 4 plus 16, 20 centimeters square, and then we will get the answer. Then now next figure, find the area of the following figures. Just observe this figure. We have here actually two figures, one is square and another is the trapezium, that is trapezium upon the square. So now here we have the measurements, each side of each side of a square is 18 centimeter, each side of a square is 18 centimeter, and here the parallel sides of trapezium 7 centimeter and other side is 18 centimeter. Children, see this properly. And height, that means the distance between the parallel side is given as 8 centimeter outside. Okay, see carefully and draw these diagrams neatly. And now area of given figures, then area of a trapezium plus area of a square. Just keep the textbook also at your front and draw these diagrams as like in the textbook. Okay. Now area of a square is side into side. Then area of a square we can get simply 18 into 18, 324 centimeters square. Then area of a trapezium, we know that half into h into a plus b, then half into 8 into 18 plus 7. Then we get 4 into 25, that is 100 centimeters square. So therefore required area is 324 plus 100, that is equal to 424 centimeters square. Okay, children? Just note down all these sums in your notebook neatly and practice regularly. Okay, children, then the other thing is area of a quadrilateral. So here also we have to obtain formula for area of a quadrilateral. So see this. A quadrilateral can be split into two triangles by drawing one of its diagonals. So this triangulation helps us to find out the area of a quadrilateral. See this quadrilateral, children, ABCD. So here the thick line, that AC is the diagonal, so which divides the quadrilateral into two parts, that is two triangles. This is why it is called as triangulation. One is ABC and other is the ACD. So now Mahesh split the quadrilateral ABCD into two triangles by drawing the diagonal AC. Okay, children, I am taking one student's name. So that's why here the quadrilateral is divided into the two parts, that is ABC and ADC. Okay, two parts means two triangles. So we know that area of a triangle can be found using two measurements, which are base of the triangle and the vertical or height of the triangle. So which is the distance from the base to its apex, that is the peak point of the triangle or point at the top of the triangle. We know that height, how can we draw from base to the peak point, that only they are telling. So measured at right angles at the base. That's why it is also called as altitude of the triangle. So this height is always perpendicular to that of the base. Okay, just to draw that perpendicular from the base to the highest point or the point at the top of a triangle. That is, here I am taking B as the top of the triangle at the first triangle, and at this side D is a highest point or the peak point of the second triangle. Now by drawing those two we will get H1, H2. So now Mahesh has drawn two perpendicular lines to AC from D and B. Those are lengths of H1 and H2 respectively. So and they named their lengths as H1 and H2 respectively. Just read that matter carefully and note down all these things. Areas of quadrilateral ABCD is equal to, by So by the figure we can write area of a triangle ABC plus area of a triangle ADC. So area of a triangle ABC is half into AC into H1 plus half into AC into H2. Why? Because area of a quadrilateral ABCD is equal to area of triangle ABC plus area of triangle ADC, that is equal to half into AC into H1 plus half into AC into H2. So here half into AC is, that is 1 by 2 into AC is common, then 1 by 2 into AC into H1 plus H2. So area of quadrilateral is equal to 1 by 2 into, that AC is taken as D, so 1 by 2 into D into H1 plus H2. So where D denotes the length of the diagonal AC. So by this way we can obtain the formula for area of quadrilateral. Now let us see one sum here. So calculate the area of a quadrilateral ABCD when length of the diagonal AC is 10 cm and the length of perpendiculars from B and D on AC B is equal to 5 cm and DF is equal to 6 cm respectively. So draw the figure and write the question. Try to do this sum. Now here we have area of a quadrilateral formula. We know that half into D into H1 plus H2, and here D value 10, H1 value 5, H2 value 6. Substitute them, half into 10 into 5 plus 6. So simply we can get 5 into 11, that is 55 centimeter square. Okay, sir. Now, okay, children. Then here we get the other sum. Very important. Find the area of the this following figure. Here, actually, this figure is a irregular polygon. Actually, in this here we have just A, B, C, D, F, E, EF around this flat. Here, A, B, C, D, E, F, they are the surrounding points of this flat. Then we have to find this type of figure areas by partitioned in our own known figures. Okay, so just right side of AD, observe that right side of AD line we have two figures. One is DHC triangle and other is trapezium ABCH. Okay, children. On left side we have two triangles. One is AGF and actually it is IED. Okay, children. Write there I at 80. So next the trapezium is simply you can write HEFG. Okay. Okay, children. Then now we need to get the areas one by one. Here are actually 5 figures. So now the area of the figure is equal to the sum of areas of all figures. We know that one. Now first of all find the area of trapezium ABCH, that is H value 80, that is distance between the parallel sides 80, and each of lengths, that is A is equal to 50 and B is equal to 40. Those two are the actually measurements. Actually 50 that side, 40 this side. Okay, no problem. So while making in your notebook, just write it correctly. So HC is 50 and AB is 40. Okay, children. So next follow up that one. Then here we get half into 80 into 50 plus 40. Then we get 40 into 90, 3600. Okay. Now next, area of a triangle HCD, that is half into base into height, half into 40 into 80, that is 1600. Area of triangle AGF, that is half into 50 into 50, 250. Area of trapezium GIEF, again half into H into A plus B, that is half into 70 into 60 plus 50. Area of triangles are very easy, just you can observe only the trapezium carefully. You can just that only you have to practice. Okay, so see here the H value is 70, A value 60 and B value 50. By substituting that we get half into 70 into 60 plus 50. Then 2 1s are 35s are, and 60 plus 50 110, 35 into 110, 3850. Now area of triangle IED at 80 just write I, then we get IED there, then half into base into height, you know that one, base is 60, height is 40, all measurements are there, and just substitute them and get the results. 2 1s are 2 30s are 30 into 40, 200. So by combining all these values we get simply 3600 plus 1600 plus 1250 plus 3850 plus 200. Then the sum of all these values is equal to 11,500. Okay, children. Now let us see. So once again, I did that sum. Now area of circle, children. This is also a main concept. Here we can find the area of a circle by using graph also. See this, let us find the area of a circle using the graph paper. Draw a circle of radius 4 cm on a graph paper and find the area by counting the number of circles enclosed. Got it done? Simply we did this type of areas in 6th and 7th classes. As edges are not straight, we roughly estimate the area circle by this method. Okay, approximately we can estimate. Now there is another way of finding the area of a circle. Okay, yeah, very interesting. See this, here we have 3 figures. Draw a circle and shade one of the circle as shown. Just draw a circle and shade half of the circle as shown in the figure 1. Now fold the circle into 8 equal parts. Okay, children. And then next, and cut along the folds as shown in the figure. Just after folding, again unfold it and next cut each every part along the folds. Then we get here actually 4 unshaded sectors and 4 shaded sectors and arrange them like shown in the figure 3. Arrange separate pieces as shown in the figure 3, which is roughly a parallelogram. Now again, more sectors we have the nearer to reach an appropriate parallelogram as done above. If we divide the circle again 64 sectors and arrange the sectors, it is given nearly a rectangle. Okay, if we did more and more times, that is, if it is nearly 64 sectors, if we divide and if we fold the circle as much as more times, then we get a rectangle shape. So what is the breadth of the rectangle? At this stage it seems to like a rectangle. What is the breadth of the rectangle? Yes, by observing that we can say breadth of a rectangle of is equal to the radius of that actual circle. As whole, the circle is divided into 64 circle and on each side we have 32. So the length of the rectangle is the length of the 32 sectors. So which is what? Half of the circumference. What is circumference? 2 pi r. 2 pi r half means pi r, like that. So now we get easily area of a circle by equating area of a rectangle formed, which is a known area. That only we are getting all these formulas by knowing areas. Already we well known that areas, well known that all each and every figure areas. So area of a rectangle is thus formed is L into B. So your length is half of the circumference into radius, that is half into 2 pi r into r, then 2 gets cancelled, pi r into r, pi r square. Thus we will get that areas of these type of figures. Okay, children. So let us learn remaining sums and remaining concepts in the next video. Thank you. So area of circle is